flip-flop memory cells. This is a basic flip-flop memory cell. We've got flip-flop with D connected to, so IO represents the input-output line or the data line. So D is connected to the data line, Q is connected through the tri-state to the data line, and we connect it through the tri-state so we can connect it and disconnect it as we need to. We can get many different flip-flops attached to the data line one at a time with the tri-state. We've got a write signal, W, going into the clock here, so when this arises, D gets copied into Q, and R is the read signal, so when R goes high, Q is connected to the data line. When that's low, Q is disconnected from the data line. Let's go through the signals that are needed, the sequence to write and read data. So first of all, we start off with W is going to be high and R is going to be low. And then we're going to set the data on the line. On this timing diagram, this means that the input-output line, data line, is floating. And what happens here, this is a transition, the diagonal lines, and then we've got data on it. So it's either going to be high or low, it doesn't matter. This is just indicating it could be either. And what we're going to do is we're going to pulse W low, and it's on that rising edge here. When W rises, D is copied into Q, so it's now copied in there. And we need to make sure that W is high and R is low. That's the default setting at the end of that. So the data is now copied in. And to read it, we start off that we've got W is high, R is low. We need to make sure that the data line is floating, so it's not connected to anything. So when we get the connection across here, there's no conflict. And then what we're going to do is we're going to make R go high, which is going to connect to the tri-state, connects across there, so it's going to enable it. And whatever was stored in there is now connected to the input-output line. If we make this low again, then the data line is going to be floating again. Now to connect this in with the what we've got in the memory modules, we need to make the read and write lines from the control pins. So we've got control pins here, write enable, chip enable, and output enable. We're going to connect them using these logic gates, an OR and a NOR. We've got truth tables down here that I'll refer to. And the timing diagram, we've got the control inputs, we've got the read and write signals, and we've got the data line here. So to write, first of all, what we need to do is make sure that we've got write enable, chip enable, and output enable all high, which means, looking at the truth tables, write's going to be high and read's going to be low, as we had previously. We're going to set the data on the data line, and then we're going to hold, first of all, WE low, so it's going to tell the chip to get ready to write, and then we're going to write when chip enable goes low. So if we've got both of these low, W is going to be low, and as soon as chip enable goes high again, it's going to go high. So W going high, the data is now copied into this flip-flop. And we've got to just make sure that all of the control lines are held high again as the default setting. Now to read, so we'll start from this position. To read, first of all, what we've got to do is we've got to make sure the data bus is floating, so there's no conflict when we do the connection there. And then what we're going to do is we're going to make output enable go low. And this is going to tell the chip, get ready, prepare to output. And then when chip enable goes low, we've got low and a low, which means R is going to be high. So R is high, which enables the tri-state. So whatever is held at Q is now connected to the data line. Once we've finished, once we're ready to do that, just make chip enable go high again, which makes R go low, which disconnects the data line. And then at the end, get into the default setting where we've got all three control lines are high.